Assalamu alaikum, brother. What up? Salaikum salam. What's good with you, brother? Nice to meet you. They call me the scammer. Can I borrow your time for a little second? No, not for real. Motherboard already on my head for messing up them financials. No, it's just for a little second. It's about the financials. Yeah. But hear me out. Bitcoin and the golden ratio. You heard about that? Yeah. Yeah, I heard that. Yeah. See? Yeah, let's go. Come on, I got you. Let's go. That's a bit.
A few moments later.
All right. Welcome to this pre-recorded session of why we in the cyber society value math the way we do. My name is Processor Abi, and today I will be showing you the world of pure, the implied, and the important side of math. And to hopefully show you that math is not hard until you can break it down. I will be available for any questioning in the live chat, so if you come up with one, free feel to ask. Anyway, pure maths, what is it? Pretty much is the seamlessly unimportant side of math, but it's really just the blueprint to all the cool stuff that's in the applied side of math. Applied math, you got pretty much, it's like Mythbusters for math, you know, Mythbusters for the universe, you understand? It answers a lot of the universal questions, the universal mysteries. That's what applied math does, but that's also really complicated. But there's a third side that not too many people know about. I like to call it the important side, the basics, the foundation, the need to know how to break down to do the big stuff. You understand? All right, we're going to talk about the most basic, important side of math. That's numbers and counting. Counting has been a part of life since the first cell divided, or since Eve had to add up however many leaves to cover up a body. If you were offended by any of those statements, please take it up with HR and not me. I'm just trying to do my job, and that's their job. Thank you. It's so natural, we even have a name for it. It's called Fibonacci sequence. But let's run it back a bit. We have a negative count, and we got a positive count. And we also got numbers in between those whole numbers. So, how do you count? Simple. 1, 2, 3, 4, 5, 6, 7, 8, and you just keep going. But let me show you a different way how to count, because if you know how to count and visualize it with the physical representation in your hand, math becomes that much easier for you. So you see my hand, right? I can count 12 just with these 4 fingers. I can count up to 12 with these 4 fingers. Let me show you how. You see these little spaces in between your fingers, the little segments? You got 3 of those on each finger. Some of the studious viewers would have figured out that's 12 segments, so you could count up to 12 on 4 fingers. Don't credit me for that. That's on some culture stuff from over there on, like, you know, India, Pakistan, China, and all that stuff, you know, Asia, Eurasia, whatever. With the Fibonacci sequence, it's just the world's naturally occurring numbers. Some people like to bring in the golden ratio with that, but that's a whole nother thing in and of itself. But what the Fibonacci is essentially, you start with 1, add it to itself, you get the 2, then you take that 2, add it to one of the 1s, and then you get 3, and then you get that 3, you gotta add it to the 2, and then you get a 5, and you gotta take that 5, add it to the 3, and then you get an 8, and you gotta take that 8, add it to 5, and then you get a 13, and it keeps going. That is the Fibonacci sequence. And the golden ratio is a specific number. I'll have it on the screen. I don't remember it off the top of my head, but if you want to get into that, because theory is that's the basis of all life. Like everything ties to the golden ratio, but you can do your own research into that. I did, and I won't spoil anything for you because that's my research. Anyway, Fibonacci. You can keep going with the Fibonacci, practicing adding your arithmetic with that adding with the Fibonacci as long as you can go. But eventually you'll get tired, and I'm gonna just need you to do the inverse, the exact opposite. Instead of adding numbers, you take away, and practice both of those until you feel comfortable. Multiplication and dividing is also an arithmetic form of math. I don't even know if those are real words, but I said it and you know what I meant by it, so yeah. Anyway, that's the other side of arithmetic, and it's not complicated at all, because like what I said in the beginning, as long as you can break down math, it's just tedious. It's not hard, you know. And what is multiplication at the end of the day? You're essentially just adding a number to itself multiple times. So if you get 3 times 5, you're adding 5 3 times, or you're adding 3 5 times. The inverse is of multiplication. Inverse of multiplication is dividing. That's basically trying to find however many numbers can go inside of another number. So how many times can 2 go into 4? That's 2 separate times. How many times can 3 go into 9? 3 separate times. You know what I'm saying? They want that clean cut number, but sometimes you don't get that clean cut number, and you gotta add a few decimals onto it. You get that perfect, even, balanced number. And of course, just like counting, if you need more in-depth with it, or if you got an answerable question in the chat, I will attempt to answer it if I see it. I mean, if I will answer it. I will answer it. There is the more advanced arithmetic as well. Those are the exponents and square roots. They are advanced, but they're pretty simple to understand, just as important. So let's talk about them. Exponents is like multiplication, but instead of adding a number to itself that many times, you're multiplying a number to itself that many times. So if you see something like, let's say 9 with the exponent of 3, then it's not 9 times 3, it's 9 times 9 times 9. So keep breaking it down from there to figure out the answer if you can't figure it out from there. Now the inverse side of this is the square root, and this is essentially just trying to find the most perfect number, you know, trying to find the square root of a number. So the square root of, for example, 144 would be 12, because 12 times 12 is 144. So do you understand what an example of a perfect square root is? But then you also can get imperfect square roots too, but we're not going to get too deep into those things because, like I said, they're a little bit more complicated than the basic stuff, but just as important. If you want to go on your own volition to learn more about that stuff, because all those things help architecture, find combinations, and predict the strength of earthquakes and many other things. So if you have an interest in any of those fields, with your own time and power, please investigate, and then maybe you might find yourself sharing with a couple disgruntled employees or something. I don't know. Alright, with all that arithmeticking out of the way, if you feel like it, you can go practice your own arithmetic if you really feel the need. If you don't, keep watching the rest of the video. Okay, this is not a concept, but a tool of math. Very important thing. In fact, most of us have this in our pocket, but this is an actual calculator. Very important tool, you know. There's a lot of stuff on here, but you know, you just got to see the basic stuff. It can help you compute numbers instead of having you remember and storing all this information or writing it down on paper. You know what I'm saying? Like, say if you got a bigger number to add up, or you got to multiply and then add the multiplication You gotta multiply these twice. You know what I'm saying? It's like a lot of, different structures and, just a lot of calculations going on. So this right here will help you keep track of that and, just real quick. You don't gotta think about the basic ones. So when you go to the more complicated side, you just type that on your calculator and you'll get the answer to the simple question, and that simple question will help you get closer to the more complicated problem solving. Order of operations is not that important, but what makes it important is that everything we've talked about so far, mostly everything we've talked about so far, is pretty much rolled up into that. So if you want to practice everything in one go, order of operations is where you gotta go, right? Because essentially it's please excuse my dear Aunt Sally. And what's that? It's parentheses, exponents, multiplication, dividing, adding, and subtraction. Please excuse my dear Aunt Sally. And the only thing you don't really know is parentheses, and that's really easy because all it is just saying what's ever in between the parentheses or brackets or whatever else can represent a parentheses. That's what you have to focus on first, and then you just continue down the list, exponents, yada yada yada. You know what I'm saying? Like I said, not really that important, just more for convenience sake, practice wise. Last but not least, we have units of measurements and their conversions. Now, depending on who you are, they might not be important to you at all. But unfortunately for y'all in the cyber society, you most likely will come across an opportunity to use some of those. And all I need you to do is look at this list, find your appropriate units and their conversions. And then once you drop that information in the chat, you'll be free to go. And when you come back next week, make sure you complete the homework, turn that in so you can actually join in. Because this is not just something for you to watch. This is retraining, and I'm gonna need you to do it, because if you don't do it, I'm gonna have to do it again, and I don't want to do this again. Hopefully you understand everything I've talked about and you have no more questions. But if you have any more questions, I will be available for 10-15 minutes. You can rewatch the video if you need to. If nobody is really asking any questions, I probably will most likely get off in like 5 minutes. All right, enjoy the rest of your day.